Okay, hi everyone. Welcome back to Introduction to Probability. So today we're going to be covering representing probabilities. Let's take a quick look at what today's session is going to cover. So as a quick recap from last session, I just want to remind us of some of the things that we covered. So what I put at the top is the key idea which has been highlighted. For all outcomes of an event, the probabilities add up to 1. So that was one of the key ideas we looked at last week. We might be doing some more questions covering that today. So remembering that when you have outcomes of an event, all the probabilities of those outcomes add up to 1. We also said that if those probabilities are written as percentages, then they add up to 100%, which is basically the same as 1, but in terms of percentages. If we list all the possible outcomes in an experiment, we get something called the sample space. That's something that we looked at last week. We said that basically if we list out all the outcomes, that's the sample space, and it can help us work out probabilities. And lastly, we used shortcuts towards the end of our session. So if we have a quick reminder of that, we said, let's say we have the phrase, the probability of event A. Now, rather than writing out that sentence again and again, we can use a shortcut such as P of A. So the probability of event A is written as P of A. If we have P of A is equal to 1/2, then that means the probability of event A is equal to 1/2. So what we were looking at were these kind of shorter ways of writing out phrases to do with probability. And that's really going to help us in today's session because we're going to be using this shorter format quite a bit. So what we will cover today. So we're going to be looking at how to define events. Now, that shorter version that we were looking at in the last lesson, this shortcut method of presenting statements, that's going to help us how to define events probability. We're basically going to be writing statements to do with probability, statements to do with events, and how we can define them without writing out all the long stuff. We're also going to be looking at Venn diagrams and how Venn diagrams are used in probability. Lastly, we'll be looking at the terms union and intersection and how it's related to Venn diagrams. But don't worry if not a lot of this makes sense right now. We'll be going through it at some point together. So let's begin with some warm-up questions. So I randomly pick an odd number between 1 and 10. Write down the sample space for this. And as a reminder, if you can't remember what the sample space is, it's the list of all possible outcomes. And then the second question is, what is the probability that this number is a multiple of 3? Now, I've put an equation that we've used quite a few times over the last 2 lectures, just as a reminder. So I'll give you a moment to have a think about it and attempt this question, and then I'll go through it. All right, let's have a go at this. So the list of all possible outcomes. So we have said that we're picking an odd number between 1 and 10. So that would simply be the list of all odd numbers between 1 and 10. So let's start. So we've got 1, 3, 5, 7, and 9. So that's very, very simple. That's the list of all possible outcomes, 1, 3, 5, 7, and 9. Now, the probability that this number is a multiple of 3. So again, when we want to present a probability like this, we use a fraction. On the top, it's the number of ways the event can occur. And on the bottom, it's the total number of outcomes. So let's start with the bottom because it's easiest. Well, the total number of outcomes we've just said is 1, 2, 3, 4, 5. There are 5 outcomes in total because there are 5 odd numbers between 1 and 10. The number of ways the event can occur. So what is the event? The event is the probability that this number is a multiple of 3. So let's look at all the numbers here, which are multiples of 3. So we've got 3 and we've got 9. So there are 2 ways that this event can occur. The event is picking the number that is a multiple of 3, and there's 2 ways that that event can occur. 2 ways out of 5 outcomes in total. So the answer is 2 over 5. So well done if you got that. Sorry about that, that froze for a second. Okay, another warm-up question. So the table below shows the probabilities of picking different colored counters from a bag. Fill in the missing probability. I'm going to give you a moment to have a think about it. The key hint here is that all probabilities add up to 1. That should give you a pretty clear idea of what to do. Okay, so as I just said, all probabilities add up to 1. So all we have to do in this question is add up all these numbers here, which if you take your time to do, you'd get 0.68. And then you would subtract the total of this from 1 to get the missing probability. So 1 take away 0.68 is 0.32. So the missing probability is 0.32. If you got that, well done. So that's another key idea we've just covered here. All probabilities covering the outcomes of the same event, add up to 1. Okay, what do the following statements mean? So what I'd like you to do is just write down the sentence that takes the meaning behind these statements. So the first one is P of X is 0.9. So I just want you to, write down what that means, and P of A is greater than P of Y. So just write down what statement that one means as well. Okay, so it did skip on to the next slide for about a millisecond. So if you saw it, don't worry. What do the following statements mean? Well, it's what we learned about shortcuts last week. So P of X is equal to 0.9 simply means the probability of event X occurring is 0.9. The second one says P of A is greater than P of Y. So we've got P of A means the probability of event A occurring. P of Y means the probability of event Y occurring. So if you just put a greater than sign in between, you get the probability of event A occurring is greater than the probability of event Y occurring. So I'll give you a chance to write that down if you haven't already. Okay, so moving on. So let's look at defining events using curly brackets. So this is, again, another way for us to write out events, but in a shorter way. So let's look at this first event here. It says, I roll a dice. Let A be the event that I roll an odd number. So we can present this event as so. What we're saying is we've been given an event and we're saying A is that event, that I roll an odd number. The easiest way to write this is I just put A and I say it's equal to, and then I put the list of outcomes afterwards. So because the event was that I roll an odd number, well, I know from the examples that I've just done that rolling an odd number gives me the following list of outcomes. 3, 1, 3, and 5. Because I'm rolling a dice, obviously, so these are my only options. Remember, on a dice, your options are 1 to 6. The event is that you roll an odd number, so that's my list of outcomes. Now, to say that A is the event that I roll an odd number, all I do is I put A is equal to, and then I do a curly set of brackets, and then I put my list of outcomes in here. That means A is the event that I roll an odd number. Now let's look at event B. If we say B is the event that I roll a number higher than 2. So again, I've got my list of outcomes, which is all the numbers higher than 2, which is 3, 4, 5, and 6. And if I want to say that B is this event, then I just put this into curly brackets and I put B is equal to. And that's it. That's how you present an event mathematically without having to write out the whole sentence. So I'll give you a moment to write down what you want to, what's most important. So I would just write down the notation and then the sentence next to it. I'd write down, I would say write down the sentence and then what it means. Sentence and then what it means next to it. Okay, let's move on. All right, so I've got some example questions that I'd like you to have a go at. These are more to do with defining events. So now try writing these events out using the set notation that we have just seen. So basically I've got 3 statements here and I want you to write them out using the shorter version that I've just showed you. So X is the event that I flip a coin. Let's start with that one. I want you to write it out in the short way that I've just shown you. I'll give you a moment to have a go. So for this first one, X is the event that I flip a coin. Let's think about how we'd write this out in a shorter way. So again, the event is called X. So I just put X is equal to, and then I'm going to open my curly brackets. Now, what's the event? The event is that I flip a coin. So what I do is I put the list of all outcomes in here. Now, when you flip a coin, there are only 2 outcomes. As we remember from the first lecture, you can either flip on a heads or you can flip on a tails. So heads and tails, that's a pretty simple one. Only 2 outcomes. So I'm going to put H, a comma, and then a T. And there you go. I've just defined this event. This right here means X is the event that I flip a coin, because X is equal to the list of all outcomes if I flip a coin. Have a go at the next one. Y is the event that I roll a dice and land on a multiple of 2. And obviously, if you finish that, you can have a go at the third one too. Okay, so y is the event that I roll a dice and land on a multiple of 2. So again, I'm just going to put y is equal to, open my curly brackets, and it's the event that you roll a dice and land on a multiple of 2. So let's list our outcomes if we are rolling a dice and landing on multiples of 2. So we've got 2, 4, and 6. Those are all the multiples of 2 if I roll a dice. So this is the event y. Y is the event that I roll a dice and land on a multiple of 2. That's the way of writing it. Okay, z is the event that I pick a random day of the week and it's a weekday. So I'm going to put z, I'm going to put equal to, put a big set of brackets. And it's the event that I pick a random day of the week and it's a weekday. So all the possible outcomes for a weekday are Monday, Tuesday, I'm just putting letters for now, Wednesday, Thursday, I'm just putting a TH, so it's different to the Tuesday's one, and Friday. That's it. So that's a list of all the possible outcomes. You could have written out the days in long. Obviously, I've just written out a shorter method. It's completely up to you. But now this statement here, Z is equal to MT, W, TH, F. This basically means Z is the event that I pick a random day of the week and it's a weekday. So well done if you got those. I know it's quite a new way of writing things, but it will help us in the questions that come up because it means that we can do less work. There's less writing for us to do. All right, moving on. Okay, Venn diagrams. So I'm assuming most of you, if not at least some of you, have seen a Venn diagram at some point in your life before. What we're going to be looking at today is how it's used in probability. So let's look at what we know about Venn diagrams, first of all. And if you don't know anything, then it's your chance to learn about what Venn diagrams are. So they're another way to visually present some information or data, a bit like bar charts. So you all know or should know what data is or information. Data is basically information about anything. And when we do maths, we can present that data on different forms of charts and diagrams. A Venn diagram is just one way of doing that. So if we take a look at this Venn diagram here, a typical Venn diagram will consist of 2 circles that overlap. Now each circle, if you notice in this case, this one is labeled circle A, and this one's labeled circle B. Now what these letters represent are groups, basically. This is group A and this is group B. So anything inside this circle here is basically things that go inside group A. Anything that goes inside this circle here is something that belongs in group B. Now, if there's something that belongs in both groups A and B, then it would go in this section here, which we call the intersection or the overlap, because it's where those 2 circles overlap. So anything that belongs in both group A and group B would go in this little overlap section. Now, you must have noticed that there's a big box around here. So that's been done on purpose to kind of enclose all the data here. So the reason we've got this box is it gives us this space, this kind of space around the circles. Now, what do we put in this space? Well, it's things that belong in neither group A nor group B, nor both. So if there's something, if we've been given a bit of information about something and it doesn't belong in group A, it doesn't belong in group B, it certainly doesn't belong in both, then we say it belongs in neither. So we put it in this space here. But we'll take a closer look at this in a few minutes. Okay. So what I've got here is an example of a Venn diagram. And what I'd like you to do is I'd like you to just maybe take a minute to copy this out. And then we can take a look at some of the features of this. So I'll give you 2 minutes to copy this out. It doesn't have to be very neat, by the way. This can just be a rough sketch because we're just going to be using it to understand Venn diagrams. Okay, let's take a closer look at this. If you haven't finished copying it out, don't worry. I think it's more important to pay attention to the screen right now. So we've got two groups here, apples and oranges. So as you might have figured out from what we were just talking about, the things that we've got written here in this circle apply to apples. The things in this circle are things that apply to oranges. And the things here are things that apply to apples, both apples and oranges. So we've got the words red, oh, sorry about that. We've got the words red and thin peel in this circle because those are things used to describe apples. Apples are red and they have a thin peel. In the meantime, here we've got the color orange and we've got the term a leathery rind. Rind just means peel, basically, leathery peel. So we're saying that oranges are obviously orange in color and they have a leathery rind or a leathery peel. It's not quite thin, it's quite leathery. In the middle, we've got the word fruit and grows on trees because these words apply to both apples and oranges. They're both fruits and they both grow on trees. So that's a simple enough way of looking at how Venn diagrams work. Now let's look at what happens when we have numbers in these circles instead. So take a look at this Venn diagram. We've got dog owners in the blue circle and cat owners in the green circle. Let's see if we can answer the following questions. So I'd just like you to answer these questions. You don't have to copy anything out, obviously, if you don't want to. So it says, how many people are dog owners? I'll give you a second to have a think about that. So how many people are dog owners? Well, we've got 6 people that own just dogs. We've got 3 people here that own cats and dogs. And we've got 4 people that only own cats. So how many people are dog owners? Well, we count up everything in the blue circle. So 6 plus 3 is 9. If you thought the answer was 6, well, that would only be correct if the question was, how many people only have dogs? Only have dogs. In that case, the answer would be 6. But they just said, how many people own dogs? So we include the people that own cats and dogs because they're still dog owners. How many people are cat owners? Well, similarly, again, We've got 4 people that own only cats and 3 people that own both dogs and cats, but they're still cat owners. So we add up everything in the green circle and we get 7. So 7 people are cat owners and 9 people are dog owners. Okay, now let's answer some more questions based on what we've just done. So, how many people have both cats and dogs? Well, the answer to this one is, oh, sorry about that. There we go. So how many people have both cats and dogs? Well, the answer to this is obviously 3, because 3 is in the intersection, it's in the overlap. So I know that 3 people both own both dogs and cats. How many people have dogs but not cats? Well, the answer to this is 6, because there's 6 people that own only dogs and not cats. How many people have cats but not dogs? Well, that's 4, because as we can see here, we've got 4 in the cats only section. It's in the green, but it doesn't overlap with the blue. That means it's these 4 people only own cats. So well done if you managed to figure any of those out. Okay, so this Venn diagram shows how many students in a class like tea or coffee. So I've got a Venn diagram here. We've got the tea group in this circle, the coffee group in this circle. So what I'd like you to do is have a think about these questions and try and answer as many of them as you can based on the examples that we've just done. So I'll give you 2 minutes to think about these questions. Try and work as many of them out as you can, and we'll go through it in 2 minutes' time. Okay, let's have a go at some of these questions. So first one, how many people like tea? So in this case, we're interested in everything in the tea circle. So we've got 13 plus 8 gives us 21. We've got 13 people that like only tea and 8 people that like both. So we include everything in this circle. How many people like tea but not coffee? So in this case, we're interested in things only in the tea circle and not in the coffee circle. So we've got 13 people only like tea. How many people like coffee but not tea? The answer is 7, because there's 7 people that only like coffee. How many people like neither tea nor coffee? In that case, we look outside the box here, and we know that there are 2 people that like neither of those drinks. How many people like both tea and coffee? Well, we look in the middle at the intersection or the overlap, and we know that 8 people like both tea and coffee. And finally, how many people are there in the class? So if in this case, whenever you're asked how many people are there in total in the class, you just add up all the numbers on the Venn diagram. So we've got 13 plus 8 plus 7 plus 2. So if you work that out, 13 plus 7 is 20, 28 plus 2. So you've got 30 people in the class in total. So well done if you got any of those correct. Okay, so now what we're going to be doing is figuring out how to construct our own Venn diagram. So I've got a diagram here, it's empty. Now what I've got here is a list of numbers between 1 and 16. Now I've been told that group A is multiples of 3 and group B is multiples of 4. The question says, can you figure out where the numbers would go? So what we're going to do together is we're going to fill in this Venn diagram. So, okay, so what we're going to do is I suggest we go through each number one by one and we figure out where on the Venn diagram that it's going to go. So for this part, you don't need to copy it out if you don't want to. You can just look online and do it with me. So 1, start with 1. So 1, is it a multiple of 3? No, so it won't go in group A. Is it a multiple of 4? No, it won't go in group B. It definitely won't go in both. So it's neither. So 1 will go outside the box. So that's 1 done. Okay, next we have 2. Now 2 is not a multiple of 3. It's not a multiple of 4. It's a factor of 4, but it's not a multiple of 4. Remember, multiples of 4 are anything in the 4 times table, and multiples of 3, anything in the 3 times table. So 2 is not a multiple of 3 or 4, so it's going to go outside. Let's look at 3. Now 3 is a multiple of 3 because it's a multiple of itself. So we put 3 in group A. And in fact, what I'm going to do is, it might be handy for me to just write out what each of these groups mean. So group A says multiples of 3. So that means 3, 6, 9, 12, 15. Everything in the 3 times table, basically. Yeah? And group B means multiples of 4. So we have 4, 8, 12, 16. So now I know by doing this what goes in each group. So now let's go back and fill in this Venn diagram now. So next we've got 4. So 4 obviously belongs in group B because it's a multiple of 4. Okay, next we've got 5. Now 5 is neither a multiple of 3 or 4, so it goes outside. 6 is, 6 is, look, a multiple of 3. So I'm going to put that in group A. 7 is not a multiple of either, so it goes outside. 8 is a multiple of 4, so it goes in group B. Put it in there. 9 is a multiple of 3. It's in the 3 times table, so it goes in group A. 10, neither, so it goes outside. 11, neither, so it goes outside. 12. Now, if I look here, I can see that 12 is in both. It's a multiple of 3 and it's a multiple of 4, because in fact, 3 times 4 is 12. So I'm going to put this in the middle. 12 is multiple of 3 and it's a multiple of 4. It's in both. 13 is neither. 14 is neither. Let's get rid of those. 15 is a multiple of 3. So I'm going to put that in group A. 16 is a multiple of 4. So I'm going to put that in group B. And there we go. That's it. So we have successfully sorted out this long list of numbers into the Venn diagram based on these 2 groups, multiples of 3 and multiples of 4. So if you managed to get any of those, well done. Let's just clear that. Okay, so we have a list of numbers that we've been given between 1 and 11. Let A be the group of odd numbers, and let B be the group of prime numbers. Draw a Venn diagram for this information. So what we'll do is we'll go through the list of numbers that we want, and then I'll give you a couple minutes to draw your Venn diagram and put the information in that. But let's answer some of these first, which will help us do that. So the numbers that are odd. So let's look at group A. Let A is the group of odd. Let A be the group of odd numbers. So numbers that are odd, we've got 1. Okay, we've got 1, 3, 5, 7, 9, and 11. Numbers that are prime. So if I remember prime numbers are numbers that can only be divisible by themselves and 1. So excluding 1, because 1 isn't a prime number, because when we say we want 2 numbers that can only divide by itself and 1, the itself bit has to be different. So the first prime number is 2. What else is a prime number? 3 is prime. 4 is not prime. 5 is prime. 6 is not prime, but 7 is prime. 9 and 10 are not prime, but 11 are prime. Okay. So now that I've given you we've gone through the list of numbers that are odd, we've gone through the list of numbers that are prime. So we've got group A and group B. Now we want numbers that are both prime and odd. So those will be in basically the overlap section. So what numbers have we got which are both prime and odd? We've got 3. We've got 5. Got 7 and 11. Those are all odd and prime. Now lastly, we've got the numbers that are neither odd nor prime. So what numbers in this group are not odd and not prime? So I've got 4. It's basically the numbers that haven't gone in either of these groups, have they? So 4 is not odd and it's not prime. 6 is not odd, not prime. 8 is not odd or prime. 9 is prime, but it's odd. 10 is not odd or prime. Okay, so now that I know where all the numbers belong in terms of the groups, I'm going to give you a couple minutes to draw out the Venn diagram and put the numbers where they belong. So I'll give you about 3 minutes to do that now. All right, so hopefully you should have your Venn diagram drawn out with the numbers in it by now. If not, you can just look at the screen and see what it's going to look like. So very quickly, numbers that are odd, we put everything that's odd in just A. So, oh, wait, let's undo. Okay, so first of all, what I'm going to do is I'm going to take the numbers that are both prime and odd, and I'm going to put those in the overlap section, because that's the easiest bit. We put 3, 5, 7, and 11. Now, that in terms of the numbers that are odd and not prime, well, the only one that we've got here is 1. So we put 1 in here. In terms of the numbers that are prime and not odd, we've only got 2 here. So we put 2 in there. We've got the ones that are both prime and odd are in here. And the ones that are neither odd or prime obviously go outside. So we've got 4, 6, 8, and 10. So that's what your Venn diagram should look like. And don't worry if you didn't manage to get this, like, it's still early days, so we'll be practicing more with it in the next lecture as well. So clear. That's what your Venn diagram should look like. Ah, yes, there should be a 9 in here too. I think I may have left that out in the previous slide. So I've got this up just in case. So that's what your final Venn diagram should look like. I'm just leaving this up a moment more in case anyone didn't get that. You can quickly jot that down. Okay, so now let's answer some questions to do with probability. So what I've got here is I've got the Venn diagram that we just did in the previous question. So in case you were unsure about your final output, I've got it written in the corner of the screen just here. So we can look back at this to help us answer these questions. So I pick a number at random from the diagram. What is the probability that this number is odd? So what I want us to think about is this equation that we looked at in the previous few lectures, which says the probability of an event occurring is, again, the number of ways over the total number of outcomes. So I'm picking a number at random. What is the probability that it's odd? Well, let's draw this in. There we go. So I present my fraction. I know that the total number of outcomes is just, well, that's the number of numbers that we've got. So it was 1 all the way through to 11. 1, 2, 3, 4, 5, we count, get 11 numbers in total. So that's 11 outcomes. Now the probability that that number is odd. So again, I want everything that's odd. So everything in this blue circle here. So how many odd numbers do we have? We've got 1, 2, 3, 4, 5, 6. So I've got 6 out of 11. 6 possible ways of picking an odd number and 11 numbers in total. So the probability of picking an odd number is 6 over 11. Okay, what is the probability that it is prime but not odd? So I'm picking a number at random, and what's the probability that it's prime but not odd? Well, in this case, again, I know it's out of 11. I'm picking a number that's prime but not odd. So I'm going to look at this section here, this circle, which looks at prime numbers. I don't want anything that's odd. So I get rid of anything in the overlap. I just want this number here, the 2. There's only one number that is prime but not odd. There's only one option. So I put 1. 1 over 11 is the probability that I pick a number that is prime but not odd. Okay, next question. I pick a number at random from the same diagram. This time they're asking, what is the probability that it is neither prime nor odd? Meaning it doesn't belong to any of those groups. Okay, so again, I've got 11 outcomes in total because there's 11 numbers. I'm interested in numbers that are neither prime nor odd. So I'm looking at everything outside the circles. So I'm looking at all of these. 1, 2, 3, 4. There are 4 options which are neither prime nor odd. So that gives me 4 over 11. Well done if you got that. Okay, so we've used Venn diagrams to work out probabilities. Let's look at the union and the intersection. So let's just describe these words to start off with. We use the words union and intersection to describe the groups of numbers in a Venn diagram. So we have briefly already looked at the intersection. The intersection I told you before is just the overlap, but let's look at exactly what it means and how we write it out. So first definition, the union. The union of 2 sets is everything inside set A, set B, or both. So you don't have to write any of this down, don't worry, but I would suggest just looking at this diagram here. So the union of set A and set B is everything that's inside A, everything that's inside B, or everything that's inside both. So that's why everything in yellow here is the union. And the way that we write that is we present it with the letter U. So we write A, U, B, means A, union B. So everything inside A, everything inside B, or everything inside both. Now, the next definition we have is the intersection. The intersection of 2 sets is everything inside the both section, i.e. where they overlap, where they intersect or where they overlap. So if you look at this part here, A intersection B, the intersection is just everything inside the overlap. And we used this kind of upside down U, it's like an N basically, to represent the intersection. So we've got the union, which is everything in both, and we've got the intersection. Okay, so let's take a look at this Venn diagram. We've sorted the numbers 1 to 6 and we've put them into groups. Let's define the union and the intersection. So if you look at these Venn diagrams, we've got the numbers 1 and 2 in group A, 3 and 4 in both, and 5 and 6 in group B. So A, U, B, that's the union. The union is everything inside A, everything inside B, and everything inside both. So for the union, we'd write all the numbers between 1 and 6. For the intersection, we would put all the numbers that are in the overlap. So we just put 3 and 4. So all we've really said here is that the union is all the numbers that are in both, and the intersection are the things just in the middle. We'll have more practice on this in next week's lecture, so don't worry if it's not making a lot of sense right now, or you want to get stuff down. At the moment, we just have to understand what those words mean. Okay, so one last question before we finish off. See if you can figure out the union and intersection. You can use the letters G and H for each group. So what we've got here is we've got a Venn diagram, and we've been told that the people in this group like geography, people in this group like history, and there's this many people that like both, there's this many people that like neither. So let's write down what the union and the intersection is going to be for this one. Okay, so the union, as we just described, is everything in both G and H and both. So the union we'd say is 40, 14, and 52. That's the union, that's everything that is in both, in G and in H and in both. The intersection is just the overlap. So the intersection gives us 14, right there. And that's it. That's all we're really doing at the moment. We are literally just defining where the numbers would go if it's in the union, and where it would go if it's in the intersection. So well done if you got that. Oh, let's clear that. Okay, so the summary for today's lesson. So Venn diagrams are useful to calculate probabilities, as we've just worked out. Now, what we can say is we can combine, if we combine everything that we've learned so far, we know that this symbol here means, I think that's actually a small mistake here. So what I'll do is I will write this out again. So let's just ignore that for now. Okay, so if I have A union B, I'm putting an A, U, and then a B. So that means everything in the union. And if I put a P around those groups of letters, it means the probability of picking something inside A union B. If I put P around these set of letters here, it means the probability of picking something inside A intersection B. That's me combining all the terminology that I've done so far. Now, what we'll do in next week's lecture is we'll write these definitions out properly, and we'll be answering some questions based on what we've just done. Okay, so I think we will finish there for today. Thank you so much for listening, and I will see you in the next lecture.
Thank you so much for that, Iram. It was very useful and very informative. So thank you so much for telling us all about probability and Venn diagrams and introducing us to unions and intersections too. Thank you so much. And I also want to say a big thank you to our other tutors, Michael and Maria.